And now we are asked to consider the situation where the switch has been closed for a long time. So we kind of came to an equilibrium value of current flowing here through the inductor. And then we're going to open the switch up. So it will disconnect the battery. And we know what's going to happen is that the inductor will want to keep the current flowing. So even though there's no longer a battery there, the inductor is going to keep pushing current through these loops here. It's probably useful to rewrite this circuit here because when the switch is open I can combine, well actually at any time I could combine these the left two resistors in parallel. So I'm just going to rewrite the circuit here with my resistor, my inductor, and this equivalent resistor here. They were in parallel, so that's R over 2. R and L, sorry that's not very legible. And then I can do this one more time because now I see the resistor R over 2 and the resistor on the right R are actually in series. So I can rewrite this just so it looks a little bit nicer as a single resistor, which is 3/2 R, and the single inductor, which was just L. Now, it asks us about the current a little bit after that switch is open, 3 microseconds. And here I'll need to recall that the current as a function of time is just equal to the current at t equals 0, and then it's going to exponentially decrease over tau, and the time constant is given as the inductance divided by the resistance. So here, what we'll use, our inductance will be 53 microhenries, 10 to the minus 6, and our resistance is this equivalent resistance of 3/2 R. So we'll take our 17 ohms and multiply it by 1.5, and we get 25.5 ohms here. And when we put that all together, we get a time constant that is, just one second, is 2.078 microseconds. And so we can just substitute that into our expression up here. And what they really ask is for the current at 3 microseconds divided by the maximum current. So that's just going to be e to the minus t, which was 3 microseconds, divided by tau, which is 2.078 microseconds. Again, I'll put that into my calculator and see that it's down to about 24%, 0.236.